So you've been assigned the free response number 183. This is a no calculator AP Calculus problem. And I want to give you a few hints and tips on this thing. We'll read through the problem here on this first slide, and then we'll work our way through part A, B, C, and D and give some hints and tips for each of those so that you can hopefully finish it off on your own if you're stuck. So for this problem, we are given this diagram here at the top. I notice that it says this is the graph of G, and then we have to read about what G is. And so please make sure you always read all the words for these problems. The graph of the continuous function G, the derivative of function f, is shown above. Now, in that sentence, notice they told us something important, that g of x is actually the derivative of f of x. So we are looking at a derivative when we look at this graph. The function g is piecewise linear from -5 up to 3. From -5 less than or equal to x is less than 3. And g of x is the parabola 2 times x minus 4 squared for 3 to 6. And you can see that by just visually looking at the graph here. The pieces from -5 over here on the x-axis all the way out to 3 on the x-axis, all of these pieces here are just little line segments. That's why it's saying they're linear. And then you can see here on the end we've got a parabola to finish this thing off. It's a piece of a parabola. So that's how G is built. And just through experience, I happen to know that the reason they're telling me that is I'm going to need at some point to probably compute the area. And so I'll use geometry to compute the area of these linear pieces because they make shapes like triangles and squares. And I'll use calculus to compute the area under the curve for that parabola piece. And then we have 4 parts that we're going to complete for this particular free response problem. So letter A says, if f of 1 equals 3, what is the value of f of -5? To me, that indicates that I'm going to have to do some kind of accumulation because I'm given this initial value here, and then we know we have the graph of the derivative, but we have to construct function f so that we can plug in -5. So we'll probably do some accumulation there. For letter B, we're simply going to evaluate the definite integral on g of x from 1 to 6. Simply put, we are going to figure out the area under that curve. For letter C, for -5 to 6, so in other words for the whole interval there, on what open intervals, if any, is the graph of f both increasing and concave up? And then we'll give an explanation. And finally for letter D, find the x-coordinate of each inflection point of the graph of f. So this question is about f, which we don't see here. It's not about g. And we'll give a reason for our answer on that one also. Let's put our focus back to letter A, and let me give you a few hints on this one here. So we recently started talking about accumulation. And accumulation is basically a way for us to build a function f if we have an initial value and if we know something about the derivative of f. So in general, that accumulation function looks something like this. F of x, our function that we're interested in building, is going to equal the initial value f of a, so that's the y value there, plus any accumulated change from a to our point x that we're interested in. And then we integrate the derivative of f over that interval. So that's the general formula. And we're going to use the information in this letter A to help set up our formula. So basically we are looking for f of -5. And I'm going to use a little different color here, but I am going to make that -5 red because it's playing the role of x in this situation. We are told that we know f of 1, right? We know that f of 1 is 3, so let's just go ahead and put this in. And then you'll replace f of 1 with the 3 when the time comes. And then to build the rest of this definite integral, we have the integral symbol, and then the limits of integration. The bottom number is the a, so that's the That's the 1. Oops, I picked the wrong tool there. Let me get rid of that. The A is the 1, the bottom number. The B is the -5. And then we're going to integrate the derivative of f, which we said over here was just g of x. So let's just put g of, you can put g of x or g of t. We usually use g of t on this piece because x is typically saved for this spot here. So if you take that 3 and add on the accumulation, in other words, the area under the curve between 1 and -5, you should get the value for f of -5. Now I want to make a couple of little points here. The first one is, notice that the A and B are out of order. We typically don't compute area from right to left, we compute it from left to right. And so if you want to put that in the correct order, what we'll do is we'll change this symbol. So I recommend that you rewrite this as f of -5 equals f of 1 minus the definite integral from -5 to 1, because then things are in the order that we're used to. I'm just sort of trying to be efficient with my colors here. G of t dt. Okay, so, oops, I forgot to write the 1 in there, didn't I? Okay, so that f of 1, remember, we already know that answer. So you'll fill that in. I'm not going to write it here, but I will circle it. It's right there. So you're going to put that 3 right here. And then you have to calculate the area under the curve from -5 up to 1. Well, that's just a bunch of shapes, right? So there's a square here. You'll calculate this area. And there's a triangle here. You'll calculate that area. Both of those are negatives. So when you're writing those numbers down, make sure you write those negatives. And then there's no area right here, and then there's a little bit of area right here from 0 to 1. That's a positive area. So calculate this total and put that here, and then just do 3 minus whatever that number is, and that'll be your value. So I gave away quite a bit. Hopefully you can finish it off. Again, the only reason you're coming to the video is because you got stuck, so I figure I better give you quite a bit. Let's move on to part B. All right, so let's take a look at letter B. Letter B should be easier to address. They simply want us to find the value of this definite integral. Essentially, they're saying find the area between the curve and the x-axis from x equals 1 to x equals 6. And I'm going to recommend you break that into 2 pieces. From 1 to 3, we just have a square. So figure out the area of that thing and write it down. So A is going to be the area of that square, which I'll just put in blue. You'll write that down. And then we're going to add on the area between the curve and the x-axis of this parabola. And we know now that we use the fundamental theorem to figure that out. So we're going to write a definite integral. That would be the definite integral from 3 to 6 of g of x. Now out there, from 3 to 6, g of x is this parabola. So we're going to do 2 times x minus 4 squared dx. And we're going to compute that definite integral. And remember, this is a composition, so we'll have to do some u substitution. I recommend you make u equal x minus 4. When we do our derivative, that means we get 1, so dx equals du. And because this is a definite integral, we're going to stay with u because u is good. So we're going to convert that top number 6. So u of 6, we're going to do 6 minus 4, which is 2. And we'll convert the bottom number 3. 3 minus 4 is -1. And we'll put 2 up here and -1 there. And then this thing just becomes 2u squared, and you'll do your antiderivative, and you'll plug in your 2 and your -1 to compute that value. So you'll get this value, and you'll add to it the blue square that you figured out there. And then you'll have the answer to this definite integral down here. So that's it for that problem. Okay? Let's look at number 3 on the next slide. I think I said number 3, but what I meant was part C. In this case, they're asking us on the open interval, right, from -5 to 6, so on the whole picture here, on what open intervals, if any, is the graph of f not G, but F, increasing in concave up. So remember, when a function's increasing, its derivative is greater than 0. That's what this is saying. We're increasing, so the first derivative is greater than 0. And when it's concave up, the second derivative is greater than 0. Okay, so in other words, this is saying where is g of x positive and where is the derivative of g also positive. Well, on this graph, the way you figure out where g is positive is you look above the x-axis. So that's essentially on this side of the graph here. That's where g is positive, from 0 to 6. And in those sections, we have to figure out where the derivative of g is also positive. In other words, we're going to look at the slope of the graph in this area. And I notice there are two places where it's positive. It's positive there between 0 and 1. And it's positive here between 4 and 6. So you're going to write those intervals in. I guess I gave away too much on this one. But write those intervals in for your answer. Okay, since I said too much for that one, let's quickly move on to letter D and then see if I can get out of here without giving away that answer. So let's talk about D, as I mentioned here. That's down here. Find the x-coordinate of each point of inflection of the graph F. F is not pictured here, remember. Okay, so here's the deal. You need to know the definition for an inflection point. An inflection point is where a curve changes from concave up to concave down, or from concave down to concave up. Now remember, we use the second derivative to identify the concavity. So what we're really saying is the second derivative changes from positive to negative or negative to positive. We are looking for places where the second derivative changes from negative to positive. Well, remember, the second derivative of f is just the derivative of g. So I'm looking for places where the derivative of g changes from plus to minus or minus to plus. And the derivative of g is on this picture, right? It's the slopes of this picture. So for instance, here is a positive slope. Here is a positive slope. Here is a negative slope. Here is a positive slope. Are there any places where this thing changes from positive to negative? And if so, write the point down and explain why you chose it. That's what you have to do on that last one. Okay, so this is our hints and tips video. Hopefully this helps you finish off this free response problem. And then obviously as we practice more of these, we're trying to get to the point where we can do them without peeking at the hints. But I think right now it's okay to do so. If you need me, you know where to find me. In the meantime, take care.